Okay, so we're going to do the sixth lesson in trig 6 today, and it is, we're starting into proving identities and trig rules, okay? So the nice thing about this is that these types of proofs are not the same as your geometric proofs, and so today's going to be a little bit differently, but just realize this is where the lesson is going. We're going to learn how to prove things. So we're going to start with these identities. You're going to want to write these down somewhere. This is something that when we have a test over this, you're going to want to put this on a note card, all of these rules. So the very first one's called the quotient identities. And basically, it takes tangent. Okay, we're going to call tangent of t. That's the name of the angle that we're going to be dealing with when we deal with proofs and things like that. It's the same thing as sine t over cosine t. So it's just important that we know that. All right, that this is something you probably use enough that you memorize it. Okay, and then likewise, cotangent of t is the reciprocal. So it's cosine t over sine t. Now again, as I'm writing these down, you're going to want to write these down somewhere because I'm going to be referring back to these repeatedly on the examples, so make sure you have these. Okay, the next one's called the reciprocal identities, and most of these you should know already. I'm going to write them down anyway, because these are the things we're using. Okay, so we have 6 trig functions. Sine t is 1 over the cosecant of t. Okay, the cosine of t is 1 over the secant of t. The tangent of t is 1 over the cotangent of t. The cosecant of t is 1 over the sine of t. All right, I'm hoping you're seeing patterns here. The secant of t is 1 over the cosine of t. The cotangent of t is 1 over the tangent of t. Again, I would recommend that you write these all down. Okay, you're going to want these. These are what you're going to be referring back to. Okay, so we're not done yet. We have 2 more that we're going to talk about before we move on to today with the examples. All right, so the next ones are called the Pythagorean identities. Okay, now these ones have to do with the Pythagorean theorem. All right, now I could go through the proofs on these. That would take a long time. If you'd like to, come see me after school. I can show you why they work. But otherwise, we're just going to write the rule. Sine squared of t plus cosine squared of t equals 1. All right, now, you could use any version of this. Keep in mind that so the cosine squared of t would be 1 minus the sine squared of t. The sine squared of t is 1 minus the cosine squared of t. All right, so just keep in mind that we can manipulate that in a lot of different ways. Okay, another part of this rule is the tangent squared of t plus 1 equals the secant squared of t. All right, again, remember that we can change this rule. We can say the tangent squared of t equals secant squared of t minus 1. What else could we do? We could do 1 equals the secant squared of t minus tangent squared of t. All right, lots of different ways. Okay, one more within this set. So we have 1 plus the cotangent squares of t equals the cosecant squared of t. Again, we can manipulate this to say other things. But these are the 3 rules for the Pythagorean identities. These are really important, and we will use these over and over and over again. Okay, one more. Okay, again, I'm not going to go into why. All right, these work. I'm just going to give you the rules. The negative angle identities. Okay, so the sine of negative t is the same thing as the negative sine of t. The cosine of negative t is the same thing as positive cosine t. So this is the one that always is tricky that people have a tendency to forget. All right, so the cosine of negative t is the same thing as positive cosine of t. And then tangent of negative t is the same thing as negative tangent t. All right, so now we have all of our rules. We're going to go through examples. All right, this is going to be kind of a long one. I have 7 examples for you, so I'll try to go through them rather quickly. The first few are easy. Okay. So basically what's going to happen is on your homework tonight, you're going to have problems that say simplify. Okay, simplify, right? Meaning you want to get it smaller than it is. Now I'm assigning only odd problems tonight so that you can go through and you can check your answers so you can see have I simplified it far enough. Okay, so the first one we're going to start with is the tangent of t times the cotangent of t, and I want to simplify that. Now it's super, super important that you show all of your work. This is about proving things, not necessarily I know the answer. Okay, so you must show every single step. So we know that the tangent of t is the same thing as tangent t times 1 over tangent t, which is the same thing as tangent t over tangent t, which is 1. Again, super important that you show every single step. All right? Okay, let's do another one. We'll just do it on the same page here. Okay? So cotangent of t times the secant of t. All right, so let's go back to our rules and figure out, okay, that's not cosine. Okay, let's go tangent. Sorry. All right, times the secant of t. So let's just manipulate these a little bit. Okay, cotangent of t, if you remember back to the reciprocal rules, or the quotient identities, is the same thing as cosine of t over sine of t. And if you remember also that the secant of t is 1 over the cosine of t. Okay, so now we've changed them up a little bit. Keep in mind now that these cosines can cancel, and I'm left with 1 over the sine of t, which can simplify to the cosecant of t. Okay, you're trying to get it as small as possible. As small as possible. Sometimes that will mean a single trig function. Sometimes that will mean more than one trig function. It's just as small as you can possibly get it. All right, so let's look at another one. Number 3. 1 minus the secant squared of t. All right. Now, what we want to talk about on this one is okay. So on this one, we're going to the 1 minus the secant of t. If you remember back to, or if you look back at your Pythagorean identities, there's the tangent squared t plus 1 equals the secant squared t. Okay, so we're going to replace the secant squared t with tangent squared t minus 1, or plus 1, right? Okay. And so now that we've replaced that, we're going to distribute, and we end up with 1 minus tangent squared t minus 1. Okay. These cancel out, and I'm left with negative tangent squared t. And that is my answer. I can't simplify that any further. Okay, next one. This is the fun one. I have sine squared t minus cosine squared t sine squared t over sine squared t. Now, you remember back to your algebra rules, okay, that when I have fractions like this, I can actually split up the denominator, and I can rewrite this as sine squared t over sine squared t minus cosine squared t sine squared t over sine squared t. Okay, this works only with addition and subtraction. Okay, so now what I can do is I can cancel these out in this case, and I get 1 minus cosine squared t. Now, if you'll remember, sine squared t plus cosine squared t equals 1. Okay, that's one of our rules, right? So the sine squared t equals 1 minus the cosine squared t. So we can replace this with sine squared t. And that's as simple as I can go. All right? And know this is going to be kind of tricky trying to figure out where am I going, but again, that's why I'm going to give you the odd problem so that you can look at the back of the book to see, hey, have I gone as far as I need to? I would recommend that you try it first before you look in the back of the book for answers. Okay, you're trying to simplify as best you can. All right, 3 more examples. See if we get this under 15 minutes. All right, so the next one I have, number 5, is tangent t plus 2, this is a hard one, times 10t minus 3 minus 6 minus tangent t plus 2 tangent t. Okay, so the very first thing we're going to do is we're going to use our algebra skills, okay, and we're going to simplify this out, okay, using FOIL. So I'm going to end up with tangent squared t minus tangent t minus 6, okay, minus 6 plus tangent t minus 2 plus 2 tangent t. Okay, so right here I also distributed this negative sign so that I can get rid of those parentheses. Okay, now we're going to combine some like terms. Okay, so you'll notice here that I only have 1 squared, so I'm going to write tangent squared t. Okay, now I have a negative tangent t, a positive tangent t, those will cancel out. And I have plus 2 tangent t, a negative 6 and negative 6 is a negative 12. All right, and that is as far as I can go. Okay, I can't really simplify that any further. All right, 2 more. Okay, this one is fairly simple. So example 6. Sine squared t minus 2 sine t plus 1 over sine t minus 1. Now, if you'll notice this, okay, this follows this pattern, x squared minus 2x plus 1. All right, just try to, if you look at it that way, it's easier to see, okay, which I can then rewrite as x, or not as x, we're going to write the signs, as sine t minus 1 squared over sine t minus 1. Okay, now since this is sine t minus 1 squared, it's the same thing as sine t minus 1 times sine t minus 2. So I can get rid of this squared and cancel it out. And what I did is I canceled out one of the sine t minus 1. And I'm left with sine t minus 1. Okay, now a lot of people at this point will try to use those Pythagorean theorems. Okay, notice that there is no squared. Okay, if there's no squares, you can't use that. You can't use that theorem. Okay, this is as far as I can go. All right, last example, and I think we're going to do it. Okay, so number 7. Oop, this is long. Okay, 1 minus tangent squared t over 1 plus tangent squared t plus 2 sine squared t. All right, so in this one, very first thing I'm going to do is I'm going to look at how can I make this simpler. Keep in mind that your process might be different than mine. Okay, you may look at a problem like this and approach it completely different, still end up with the same answer, but you went about it differently. That is okay. All right, you look at rules and you say, hey, how can I manipulate this? So I know that this right here, by one of the Pythagorean theorem, is the same thing as secant squared t. So I'm going to write that there. I'm going to leave this up here, 1 minus tangent squared t. And I'm not going to do anything with this 2 sine squared t till I get closer to the end. So we're just going to leave that there for right now. All right. Now I can split this up. 1 over secant squared t minus tangent squared t over secant squared t. All right. Now we're going to take this right here. Okay. And I'm going to say that this tangent squared t is the same thing as sine squared t over cosine squared t, okay, because tangent of t is sine t over cosine t, okay? You can use them with squares, that's okay. And this secant squared is 1 over cosine squared of t. Now, if you remember your fraction rules, if you have a fraction above a fraction, the denominators, basically, if they're the same, they cancel out. So I'm left with sine squared t there, right? And this right here, 1 over secant squared t, is cosine squared t minus sine squared t plus 2 sine squared t. Okay, because I brought this back down. All right, so now I have a whole bunch of these things, right? Now what I'm looking for here now is to see what I can cancel out. This is sine squared t, this is 2 sine squared t. It's a negative, okay? So it's going to become, we're going to go over here, sorry, I ran out of room. We still have that cosine squared t, okay? Negative 1 and 2 is 1, so it's positive sine squared t. Okay, now I have a rule that says cosine squared t plus sine squared t is the same thing as 1. So this whole big long thing brought us all the way down to 1. Right? And that is it. These examples should all, your book problems should all look very similar to the examples, okay? I tried to pick several of them out that are similar, so good luck.